Welcome, I'm Terry Soul and this is Programming Chaos, a channel devoted to fun and interesting programming projects to help you hone your programming skills. And for today's project, as you may be able to guess, I want to be programming cloaks of invisibility. So you can see what I have here is this nice cloak. When I put it on, I disappear. And there we go, we can take it off. And of course you can see, looking at the window down here, that in fact I'm not holding a cloak of invisibility, I'm holding a piece of green fabric. And so the idea behind this project is basically it's a variation of standard green screen technology. We capture camera images and then we write a little bit of code that looks at the image and decides should it show what's actually there, or if it sees green pixels in the image, should it instead show the background. And so really, I don't have a cloak of invisibility, I have a cloak of transparency. But that has, in a sense, the same effect, right? If you're transparent, you're effectively invisible. Okay, so with that as the idea, let's get started. Okay, so I'm going to be doing this project in processing, which is an environment for actually programming in Java. And the first thing we need, and this will be true in a sense whatever language you're using, is a library to handle video. Because we're going to be capturing the video from, in this case, my webcam. And so for processing, it's quite easy. We can go under Tools and Manage Tools. Here's the window. And then I'm going to go to Libraries, and there is a video library for processing. There's one for processing 3. I'm using processing 4. So it is already installed. If you don't have it installed already, you'll need to hit the install button and wait a little bit. Regardless of the language that you're using, you'll probably need to install some sort of a video processing library. Once you've loaded the library, we still have to import it into our program. And then we're going to need a video object for doing the capture. And so the name of the class that we're using is actually capture, and I'll call my object video. So video is the object that I'm going to be using and manipulating for this project. And as I said at the beginning, in order to get the invisibility or the transparency effect, we need to keep track of what the background is. And so I need an array for the background image. I could use an image, but in fact, to speed things up, what I really want is an array of pixels, because that's much easier to access quickly. Turns out that is just an array of integers. Each integer represents a pixel. So there we go. That's going to be my background pixels. And it's going to be handy to know the total number of pixels that I'm dealing with. And the number of pixels is dependent on basically the screen size that you're using, the window size. So I've already set my window size. Before I initialize the number of pixels, I need to initialize my video object here. So that's going to be the next step. And then I'll have to fill in some details. So video equals a new capture object. And we just put in this because it's capturing sort of from this system, if you will. And then we put in the height, the width and the height that we want. And I'm just going to use the width and the height of the window. So I'm going to capture the video frames just as big as my window size. This is a smallish window size so that I get pretty high performance. You can do a larger window. It might or might not slow things down, again, depending on how fast your computer is. And then we have to tell it which camera we want to capture the image from, because I actually have several different webcams set up. So there's the one on my laptop and some external ones as well. So this is going to give me an error message, but I'm going to begin by saying these are the cameras that I want. And I happen to know ahead of time that I want camera number 2, which is actually my third camera. In order to make this work, first I need to create the list of cameras. And that's just a list of strings. The capture class, which is what I'm importing here, handles the cameras for me, and it automatically goes and looks for what cameras are available and returns it as a list of cameras. And then I know that I need camera 2. If you want, because those are strings, you can print all of the cameras and then figure out which one it is that you want to use. And that's just a for loop printing this list. So there we go. This will print all of the available cameras for you, and then you can look at that list and decide which one out of the list you want to use. And now I can say that the number of pixels that I need, and I'll use this for things like setting up my background, is the size of my video capture. So the width times the height of the video capture. And what's going to happen here is, although I'm dealing with captured video frames, which we generally think of as a two-dimensional array, as I said, they're actually stored just as a one-dimensional array, the length of which is the width times the height. In this case, I'm capturing video that is exactly equal to the width and the height of the window that I'm using. That's not necessary. You could capture a smaller frame than your window and just have the video in one corner of your window, especially nice if you want to put some sort of controls along the side. Okay, so now that I know how many pixels I need, I can create my background array. There we go. So the background array or array of pixels is just based on that number of pixels. And we need to start the video capture. So that sets up the camera. The other thing I want to be able to do is write to my window, my on-screen window. And one way I could do that is by calling, for example, the point command, which draws a single point, a single pixel at a time. But drawing to the window tends to be very slow. What we want to do instead is write to the array of pixels that's stored in memory and then have that array of pixels displayed to the window. That makes things much faster. And the way we do that is simply to say load pixels. And this gives us access to an array that is called pixels. So we now have access to the pixels array, which are the pixels that show up in the window. And so in a sense, we're manipulating the window directly rather than calling a function to manipulate the window, and that goes much faster. So this is the setup, and now we can actually start worrying about the draw function. And it's a good thing to begin by making sure that the video is working. I'll begin by wrapping everything in a check to make sure that the video is actually available for use. And once we know that it's available for use, we need to read a new frame of the video. So that's actually capturing a frame from the video. That frame is stored as an array of pixels that we need to make available using the same load pixels command, but in this case, we're applying it to that video frame that we saw. So there we go. We've read in a video frame and we've made the pixels associated with that video frame available. And now what I want to do is grab the current color. So I'll create a variable to store the current color, and I'm going to grab it from this load pixels array. And the basic idea is this: current color is equal to video.pixels. So there's our pixel array, and then whatever pixel we happen to want. So this would give me the current color of pixel number 4 out of this array. And that would be the 4th pixel over in the top row. And if I wanted to move down some rows, I'd have to put in the width times the number of rows I wanted to move down plus the number of pixels I wanted to move over. But in fact, I want to examine every single pixel in the video frame. So I'm not going to do this as an integer. I'm going to do it as a loop over every pixel. So there, that grabs every pixel for me one at a time. And here I'm using that num pixels because it's the size of the array. And now in order to get the green screen effect, I need to take that color and look at the red, green, and blue components and decide whether I'm looking at a green pixel or not. And depending on whether it's a green pixel, I'll decide whether to put in the actual pixel from the image or a pixel from the background. So for that, I want to basically say the current green is equal to the amount of green in the current color. And so to make that work, of course, I've got to define this variable. So let's go back and do that. And I want to do this for the red, green, and blue. So I'll do all 3 colors. So there we go. For every pixel in the current frame that I read in, I'm going to grab the color of that pixel and I'm going to break it down into the red, green, blue components. And I realize these are not colors. sorry, there we go. Those are integers. When I break it down into the components, I have the amount of green, the amount of blue, and the amount of red as an integer. So red grabs the amount of red out of the color. And so the basic idea is then I'm going to look at the amount of green, in fact, compared to the amount of red and blue, and decide, is this part of my green screen or not, and decide how to proceed from there. So let's go ahead and do that. And this is a place where you may need to do some tweaking depending on your camera, the lighting you have in your room, and so forth. I've done some testing, and what I found is comparing the amount of green to the amount of red and blue combined works pretty well. So if the current green, that is to say in the current pixel, is larger than the amount of red and blue combined divided by, I found 1.5 worked pretty well. Where this gets tricky is if you have something that is, for example, very dark, then all of these numbers might be close to 0, in which case you could have no red, no blue, and just a teeny bit of green, and that would trigger this, but it wouldn't really necessarily be part of your green fabric. And so I also found that it works well to make sure that you've got a reasonable amount of green. I'll put in a more than 10. And because we're using the sort of raw RGB values, these should vary from 0 to 255. So is green the dominant color, and is there some green? Am I not just looking at pure black? And you might wonder, well, why can't we just use the amount of green? Why do we have to include the red and blue? Well, if we were looking at something that was, say, pure white, white is a combination of lots of green and lots of red and lots of blue. So if we just looked at green, white would appear, in a sense, in our calculation to be green because it has a lot of green. So we have to make sure that to see that something is truly green, the green is more than the red and blue. And so if that's the case, what I'm going to do is take my pixels array, and remember, pixels are what are going to show up in the window. So I take my pixels array and I say, in this case, I don't want to use the real color, I want to use the background color. If I have a lot of green, fill in what's going to show up in the window using my background. And otherwise, we use the current color. So basically, I take the color that I captured from the video camera and use that, unless I'm looking at green, in which case I fill in with the background pixel. And then the last step for this loop is we have to update our pixels. And what this does is it says, okay, I've changed the pixel array, which is what should display in the window, but it doesn't actually display in the window until I ask the program to update it. If I run this now, it should run, but it won't work because we don't know what the background looks like yet. So we also have to capture those background pixels. And so here's how I'm going to do that. I'm going to capture the background when a key is pressed. And so when the key is pressed, I do the same thing I did up here. So I loaded the pixels from the video frame, and then I'm simply going to copy them into the background. So just do an array copy. There we go. So I'm taking a video frame, and I'm taking all the pixels from that video frame and I'm copying it into the background. So assuming there's no typos, always an iffy question, this actually should work. So here we go, I get my window. This part's a little slow because it's looking for cameras, so you can see that it's dealing with the plugins. And here's the list of all of the available cameras. And like I said, I'm using the third one. And so right now, I don't have a background. It's just taking all of the pixels and it's rewriting it to the image here. So in the draw loop, it's taking each current color and writing it back. So what I need to do now is capture my background, and I don't want to be part of it, so I'm going to have to get out of the way. Processing, it's tricky. Remember to click on the window to make it the active window, or none of this will work. And let me get out of the way here for a moment. There we go. So that captured my background, and now if I grab my green fabric, any place it sees green, instead of showing the true values, it shows the background. Right? So there we go. I am invisible. Good. The interesting thing in this case is because my chair was in view, when I put the fabric in front of me, I become invisible, but the chair in the background is still part of the background. So this has some limitations. If things in the background start moving, right, you move some books on your shelf, for example, what you need to do is come in and just press a key again to reset the background. Another place you might run into issues, if the lighting changes, things start to look a little weird. So if I hold this up, you might notice a very subtle difference in lighting, in part because, for example, I'm blocking my webcam light, and so the background might not be quite as bright as it was before. But yeah, basically this is like a green screen, slightly reversed. Instead of changing the background, we're making things look transparent. Okay, so with that in mind, there's a lot of other cool things you can do. So let me do a couple of examples just to get you started. The key again is we're looking at every pixel that meets some color requirement, in this case being green, and replacing it with background. But we can replace it with anything we want. So for example, we could just replace it with the color black. And that by itself is not too exciting, although I suppose we can take a look at it. Here we go. Now, instead of a green piece of fabric, I'm holding up what looks like a totally black piece of fabric. But let's go a little further than that. I'll add some randomness. So there we go. This is going to take about 5% of the pixels and change them to white. I did that backwards. It's turning 95% of the pixels to white. So now I'm holding up a staticky piece of fabric, which is a pretty weird effect in a lot of ways. You'll also notice, because this is looking for anything green, there are some things in my background over here that have the same static effect. So the color that you pick, you have to be careful of. This was not a problem when I was just doing the Invisibility Cloak, because it was filling in these areas here with the background anyway, so it turned out exactly the same. But now they're all being filled in with my static. If we wanted, we could reverse that probability. Let's do less than 5%. There we go. That's what I meant originally. Again, kind of a cool effect, right? I've got a fabric that is this weird staticky. And then one more example, we can use things like the current frame count to get not just a random, but a changing effect. So let's do that. So I'll begin by getting rid of the old color change, and then instead I want to define a new set of colors, and I'm going to base it, like I said, on the frame count, so it changes over time. But I'll also use the position of the pixel, so the I value here. So let's do this. So that takes the count and divides it by the width of the frame, so it actually tells me which row I'm in. And I'll add to that the frame count, so it'll change over time. And then I want to do a mod 255 because my colors go from 0 to 255. So I want to wrap around. That will give me the red component. And there's the blue and the green, but I'll offset these a little bit. So let's add, say, 100 and 200. There we go. And so now you can see what I've got. The color is dependent on the Y position, and it changes over time. And so I've got this sort of cool pattern sliding by. Not a bad effect at all. And again, because I'm not careful about my background, the same things are happening in my plants and this little button over here. So the color that you pick to look at and modify should be something that's not in your background. The drawback, in a sense, to this, of course, is that it only happens on screen, right? It's not happening clearly in real life. But, you know, here, when I'm recording this, Halloween's coming up. This could be kind of a cool thing if you're doing something like a Halloween party. Hook up your laptop to your TV, display your room as if it was a mirror, but then for your costume in particular, you've got sort of a magic mirror effect. When you walk in front of it, all sorts of weird things happen because of the colors you're wearing, and maybe they don't happen to other people. And that's a big chunk of the takeaway. now we have the ability to manipulate video on a pixel by pixel basis. And what it required was, of course, a library to do the capture. And then basically we're reading each frame, putting it into an array of pixels. And once we have it as an array of pixels, we can manipulate it any way we want. So not only can we do these green screen sorts of effects, but we could also put in blur or edge sharpening. And then from there, the next step, if you're interested, would be to apply things like object detection. And so you could make your own trail camera that watches for movement, changing pixels, and stores that data away. Basic idea, once we can read a video frame and get control over the pixels in it, we've got an enormous amount of power over what we can get our program to do. Excellent. Thank you. You can also get a nice outcome by wearing a solid shirt with a pattern on it and then removing the color that's the solid part of the shirt. Not a bad Halloween effect.